This is Math 466, Lecture 9, Part 2. Unfortunately, the camera audio died towards the end of the lecture, and the last 12 minutes were not recorded, so we will now see how fast we can do the end. So just as a quick recap, we were trying to show that the function big F is differentiable. Big F is defined as the sum from minus infinity to infinity of f of x plus n. We are assuming both f prime, and f double prime decay at least as fast as x to the negative alpha for some alpha greater than 1. We need this to make all the different sums in play converge. So we're going to show that the derivative of big F, as you would expect, is just the sum of the derivatives. And we talked about why you have to be very careful every time you have infinities, every time you try to interchange orders. So we should probably call this, g of x instead, because we don't know it's the derivative of big F. But given the fact that we are confident, we're going to just write this as big F for now. So let's look at big F of x plus delta minus big F of x over delta, subtract big F prime at x, and we want to show that as the limit as delta goes to 0 of this equals 0, that will then prove big F is differentiable and big F prime, as expected, is the derivative. All right, so let's look at the algebra. So the first part is we look at the difference. We have a sum from minus infinity to infinity, little f x plus delta plus n minus f of x plus n over delta. This is the big F of x plus delta minus big F of x over delta. We then subtract off the f prime at x plus n. All right, so we're going to break this up into two parts. The first is the small n less than or equal to big N, and then the other one is, of course, the remaining n greater than or equal to n in absolute value. So for the first part, we look at f prime of x plus cn plus n minus f prime of x plus n. So this is just using the mean value theorem. We've got 2 points here. Delta is a really small number, so since these two are very close to each other, the difference should be very small. In fact, even when we divide by delta, it shouldn't be too bad. And so by the mean value theorem, it's equal to the first derivative at some intermediate point times the distance, which is delta. So we'll call the intermediate point Cn, which is somewhere between 0 and delta. And now we have a difference of f prime minus f prime at two different points, but two very close points. So the first thing you might try is to say, well, can we just take absolute values and take the sum? Well, unfortunately, we can't do that because we would lose the cancellation from these being very close to each other, and then we would have a sum of f prime at little n less than or equal to n in absolute value. That's a lot of terms. That could be very large. All right, well, can we use some kind of continuity argument to help? We know these have to be close to each other. So if delta is sufficiently small, Cn will be small, and we can maybe make each one of these at most epsilon. The problem is the number of terms we have is n, and so we would want to say, we can always make each one of these small, but that epsilon can't depend on big N. And it might be the case that if each one of these is small, we have so many that we're summing that the resulting sum is large. So the solution is to use the mean value theorem again. And so we get f prime minus f prime at some intermediate point will give us f double prime. We'll call that point dn. And then we multiply it by cn, because that's x plus cn plus n minus x plus n. When we take absolute value to bound this, cn is at most delta. So this is going to be delta times the following sum. Now we can see why we also had to assume something about f double prime, why we needed to assume f double prime decayed rapidly at infinity. This sum converges. And now we can extend the sum here if we want from n to infinity. It will still converge. And because we have the delta here, it'll be very small. So that handles the first piece. Now we have to look at the values that are larger. So we are left with the last piece. Let me just turn the camera a little bit. The advantage of not having erased things earlier. All right, so let's see if we can get it to pivot over. There we go. And so now the other part, it's the sum n greater than or equal to big N, f prime of x plus cn plus n minus f prime of x plus n. Well, here we can actually be very crude because little n is very large in absolute value. We're looking at the tail. So we use the triangle inequality, and this difference is going to be bounded by the sum of each part. Because these sums converge, this is a decay, x to the negative alpha for some alpha greater than 1. Think of it as decaying like 1 over x cubed. So this would look like a 1 over n cubed. This is going to converge. We're only doing it from some point n onwards, so it's the tail, so it's going to be very small. So each of these pieces is going to be very small, and that's enough to finish the proof. Thank you.